Doing the echo thing.
Wait, why is... Okay, never mind.
So Zach, will you be able to do the turn-in stuff this week, Saturday,
Yes.
just for the 2 sheets?
Yes.
All right. I'll do the AVS practice sheet, which has some graphic stuff. I'll take care of. If somebody wants to volunteer for the other one, or they've already got it done, that'd be cool. Oh, that's,
It's brighter there.
that's better.
You're so business casual, Zach.
I know.
That is not.
They appreciate that in my part of the world at Google.
Ugh.
So, Christian, do you wear shorts to work?
This is my work shirt. And yes, shorts and flip flops.
Oh, nice.
I can wear that too, but I have to actually like show that I can do business casual type stuff every now and again.
Do you talk to customers?
No. It's not even because of my group. It's more because of my direct managers. They value it a little bit. You know what I mean?
Yeah.
So, once in a while.
Yeah. Turn on the charm.
Yeah.
Oh, okay. I thought that was supposed to mean a...
Wait, it was it?
It could be.
Anyway, what are we discussing first?
We have just 2 worksheets this week. Do we need to talk about last week's worksheets on binary search tree? Should we? Or about project or assignment 4?
I haven't even looked at assignment for it.
It's not.
It's not bad.
It's not bad. You'll be able to cut and paste it, and Brittany has hers up there. So.
But there,
Christian, like.
but there's we have most of it is writing and drawing, and I haven't done that part because that part is pretty boring.
All right. Well, what do we actually want to do? I don't know if we need to do the assignment because we're just doing this so that Samina can see that we've collaborated on the worksheet. So why don't we focus on that?
Let's talk about the worksheet.
We can all grab a beer and then drink it on live if you guys want.
And talk
Lap through drinks.
I don't know if she's gonna like that.
Well, are we not going to cover 28 and 29? Let me just throw them up here, just to be honest.
Okay, if you want, we can skim through.
Real quick, he says.
Come on. Where's my screen?
Ooh.
Oh, you added dots with an app? What is this?
Google Drive app?
Yeah.
Maybe it'll work for me this time.
Okay, this works well. Cool.
Really?
Same window. So.
God, I don't see anything.
You see it on mine now?
I see the name. Oh, wait, maybe I need to add it first.
Wait, this one is, which one is this? We haven't done this one yet.
Worksheet 28.
Yeah, yours is
We
28.
turned these in, so we're just being honest to go through these here.
Oh, I think I can see it now.
Can you see it? Okay.
Which one are we on?
Worksheet 28.
Oh, we're looking at Wayne's screen share first.
Oh, we are.
Except I can't get it to zoom like I want. So does everybody, did you do these? Did anybody do these actually?
No.
Do you know what they are? This is like in a binary tree, if I give you a stack of numbers, put them in there and in the right place on the binary tree, right?
Yeah,
So if they give you a list of numbers, you have to, step them and get them to be in the right place. That's all. That's the whole worksheet was pretty much about that. And then the other part was to remove one and get all the pieces in the right place after you remove them.
Well, I mean, it's only going to change if the parent node is removed, right? Otherwise, it just cuts the tree in half.
Let me see.
Do you have one that deletes?
I don't think we have one that deletes. The very last one in the very last worksheet, the second worksheet.
On the
Let's
second
delete.
worksheet, on the other worksheet, okay.
29, all the way at the end, there is a delete.
All right.
I think. Or maybe it was 28 at the end.
It was 28.
I guess it is 28 at the end. Yeah, right there. B, on B, leftmost child of the right, that part.
Yeah. In fact, that's really the whole thing to remember. Leftmost child of the right.
Right.
That's the one you pick. That's good. That's the one that moves from here, like from here. Of course, it doesn't work. There. You guys can't see that anyway. Screw it.
True.
Yeah. So
I mean, I can see your PDF Exchange viewer.
wonderful, huh? But you can't see the little things that I'm drawing on it. That doesn't help any.
No, I can't see anything.
So, unfortunately, let me try it one more time. It didn't work either.
See your arrow.
You saw the arrow? Okay. We're almost there then.
Is it 6 that
This
has the delete in there?
You have to go down, Wayne. Go down. Yeah, there.
Yeah.
that's the end right there. So
Okay. Yeah. Now we can see it.
is that all right?
Yep.
So if you delete 75, then no. Wait a second. How's this go? But it's 64 moves to the top.
You delete 75, then you take the leftmost child of the right,
Right.
but there is no leftmost child to the right.
So this is a good example
Leftmost child of the right.
of the right, which is
Of
60.
the right's like subtree or something.
Right. So if you delete 75, then the right tree is 100, right?
And there is
We didn't delete 75.
Well, let's just pretend that we did.
Okay.
delete 45.
Oh, delete 45, then sure, 64 goes up
Yeah.
because there is a leftmost child.
And that's the demonstration of the principle, really. It's the leftmost child of the right side. That's the one that goes to the top.
So what if
How do we do this?
there is no leftmost child of the right side? you just promote the first child.
Yeah, and the whole chain slides up, right?
So 75 would go at the top if 64 didn't exist.
Why would 75 go instead of 22? Because you do the right side?
Uh, because 22 has children. Unless you rebalance the tree, 75 would go up.
Explain that question.
Okay, so a binary tree can only have 2 children. So 22 can't go up without rebalancing the whole tree because it already has 2 children, 13 and 30.
Okay.
So unless
So the thing that we did on the right-hand side, you can't do on the left-hand side, is what you're saying.
you can't modify the left side.
In other words, we can't take 30 and
And
move
then,
it and like we did.
right.
Wait, what
So-
are those arrows?
Right? So this is a no-no. You can't do on the left-hand side. You can't do this thing.
Right.
It's always on this side. So if you remove the top node, it's the right-hand side. The leftmost child on the right-hand side. All right?
Right.
The right-hand side is all of this, and the leftmost child is this. Boy, I suck. All right, that's good enough.
And do you guys understand what to do when there is no leftmost child?
So when there is no leftmost child, we go 75 would go to the top.
Right.
Unless 22 on the left side didn't have 2 child, then we wouldn't have to rebalance. Then 22 would go up, or is
No, you wouldn't do anything with 22 in really at all.
Okay.
The only thing that would happen is like, so I know this dealing with databases is you would rebuild the index, and that would repopulate binary tree with the numbers that are still left in the tree. So it would basically go through, get 11, 13, 22, 30, 45, 75, 100, and 145, and then build a new binary tree that was balanced so that every parent would have 2 children, and it would be as many numbers on the left side as are on the right side from the root node. That's what rebalancing the tree would be.
got it.
And we're about to talk about AVL trees, which kind of does that as you modify the tree, in place. So it's kind of like keeping an array ordered. It's more expensive, but you can do binary searches.
So talking about expensive, what is this in terms of big O? Is it all just N or
Log n. So
log N? That's right, log N.
a completely unbalanced binary tree is like pretend that the left side is all gone, and you have 45, 75, 100, and 145.
Worst-
Then it just becomes a linked list, and that is n. O-n. So
Okay.
you would rebuild the tree, and it would be, I don't know how you rebuild 45, 75, 100, 145.
Well, the AVL stuff talks about that. I don't know whether these
Yeah.
particular numbers work, but
Science.
so this sheet wasn't hard to do, and it helped me anyway to understand the code a little better, which I'm sure is what they intended. So,
Yeah. Nice.
So let's go look at code real quick. Worksheet
Yeah.
29.
Do you guys have more than one exam this week?
Kind of. I mean, the 352 is on Sunday, but that ranges all the way up until next Saturday. So
They have names there.
Only 352 this week then?
no, 271 is due either tomorrow or the next day. And then we have a huge programming assignment for 494.
When does that due?
SQL and PHP, and that's due Sunday.
Ah!
It's all crashing
What
on
happened?
Sunday.
That's terrible, Ryan.
I know.
Yeah.
Why? How come we can always only see the left side of the window?
Oh, was just trying to figure that out.
Should we do it on the Hangout Drive thing?
Let's do that instead.
Okay.
Yeah, do that instead.
All right, let's see.
Makes it easier. Yeah, open the app.
You can
Worksheet.
share it.
Oops. 5.
Who's using Google Effects?
Not me.
29. Okay.
Who's sharing it?
We can all just see it.
Okay. Works for me.
Okay, I see it.
Where do you see it?
Huh?
Click on the drive icon.
Oh,
Like, are we in different drives? Which document are we in?
29, right?
Okay. Alex.
Angela, Allison, Arthur.
oh, I think I see it now.
Okay.
Agnes.
Wow, it's weird that you can do this. This is awesome.
It
So we
is.
can edit it from here? This is crazy.
Yeah.
Oh, I think it just embeds the app. You can make your own too, apparently. So you can have like any app running Hangouts. They have like an API or something.
Okay. So mode add. So Zach, have you not done the homework yet? Assignment 4?
No, I haven't done it yet.
So this is basically assignment 4, right?
Yeah, pretty much.
So
They change up the variables.
Yeah, they make you do a compare function, and the compare function code is in one of the videos. And the video explains how to use the compare function and how to use the void pointer instead of type. So it's pretty straightforward, really. Even I could do it.
okay, so the node add is a recursive function where if you're at a node that is empty, so if current equals 0, that means your node is empty. Create a new node and assign the value to the node and assign null values to the left and right, and then you're done. If you traverse through the node, or while you're traversing through the tree and the node isn't empty, you check if the value is less than the value of the node that you're traversing, and if it is, and go down the left side, the left child, and run through this again.
And do it again. Add note again.
And then if it's well, this isn't totally right. Oh no, yes. People not using curlies.
Their code never has braces.
At least it's
I
not
know.
left justified, right?
What?
Said at least it's not left justified.
That'd be horrible if it was left justified and no braces.
I will fight you.
Or even worse, right justified.
Oh, dude.
Good job, Brian.
Yeah, thanks, man. It's a lot of effort there.
At least I put colors to it. Or one color.
Okay, so then go down the right and add it, and when you're done, return. I don't know if this will ever get called.
Which one? Return 0? It returns false if not found.
How could it not be found?
I mean, if you enter a value that's just random.
So what this doesn't address is if the values are equal.
I think it's supposed to.
Oh, no, it does.
It does right here, first one. If EQ, remember they use EQ.
Yeah, I was talking about the still add node. I
Oh,
forgot.
still, I don't know.
Sorry.
In the project, they make you take out the EQ and replace it with the compare function.
Right.
Yeah.
Okay, so contains, you want to run through that, Ori?
It just, well, what's that? Okay, so while we're not while current doesn't equal 0, and then we're going to check if the value we're looking for is the current value. If it is, we'll return 1, and then if it's less than, we'll set it to left. Whilst we'll set it to current to right, and then I guess return 0 is when we can't find it, right?
Yeah.
Okay. Yeah. Basically, it'll just keep looping until it loops to the end, and then if we can't get this EQ to be true, it will return a 0.
Sweet.
So this is basically the binary search algorithm.
Yeah.
That's exactly what it is.
Yep.
Okay. Now we're at leftmost child. Okay,
Yes.
all this does is, while the current left is not null, we'll just keep moving current to the left.
Until it gets to no.
Yep.
Yeah, I think we need some of these things.
All right, remove leftmost child.
These are helpers, right, for remove. Anyway, go ahead.
Yeah. All right, so I was kind of confused on this. They the struct node, right? You're creating a new node,
Hmm.
but why don't you just do it here?
Yeah,
I mean, you're not using it before then,
you're not
and
using it before.
then every time you uh, run the function, if it's not null, then you don't create that node, and it saves that step. I mean, otherwise, every time you go through the tree and you recurse through the function, you have to create this new node, but then you don't use it.
Yeah, you're right. It should be like this. The only reason why sometimes I always write it at the top is because in JavaScript you have to write it at the top. But in C, it definitely you're supposed to write it whenever you use the variable. That's when you declare it.
Yeah.
So
Okay.
this makes a lot more sense.
Okay, so while there are still left nodes, or if there are no more left nodes, create a new node that is the right node. Free the current node and then return the right node, right?
Yeah.
And if it's so you're checking this current node, you've made it past because there are left nodes, then you recurse down,
Yeah.
and then
Move to the left until there's no left, and then delete it.
right.
Kind of, yeah. Yeah. What's the point of the return current? What?
I don't know.
Because it's recursive.
Yeah, but you're
Have it unwinds. You have to have something back.
Oh, yeah. Right. Okay.
I mean your recursion ends here on
But I guess
return.
I think in C, if you don't put that return, it'll give you it'll crash. It'll be like, oh, you don't have a return.
Okay, cool. I believe you.
I think I tried that before. Like I only had a return in if, and then it'll just keep saying I don't have any return.
I also think that this should be inside the.
Inside, huh?
Okay. He's walking through this one. This madness.
Which one?
Node
Remove. Yeah, node remove. Okay, that LT thing is really annoying. Like, why?
Yeah.
Like in this, they have EQ and they have LT. I'm just glad there isn't GT.
Okay, this is the last one. Let's do this. All right. If the value is less than the current value, sorry, is that true or false? False. So if the value is not less than the current value,
Yeah.
okay. So is that greater than?
Yeah.
Not less than, huh?
If it's not less, it could be equal.
Okay.
I think.
Then we check to see if there's a right node, and if so, no, if there's no right node, then
Go left.
go left and delete the right one. Otherwise, take the leftmost of the right and assign the value in there to current, and the right child to the return node of the removed leftmost.
Yes. Those are the helper functions.
Yes, and then if the value is less than, is that less than, or is that,
If it's less than 0, I'm guessing it's. I have no idea. Because the other one they compared it with equal signs.
right?
So this time they're using a less than sign.
That means it's -1.
So what is -1 supposed to represent?
I think less than, but since they use LT, I want to die.
-1 usually means false, right?
Yeah.
But then the one
Or
above they use 0. What is 0? Is 0 false? Or if -1 is false, what's 0?
false.
Equal? But then they have a EQ function, so 0 shouldn't represent equal.
Okay. Well, let's just pretend. We already turned this in, right?
Yeah, we did turn this in.
Okay, so can we just do
Hmm.
if the val is less than the current val, go left.
Yeah.
Otherwise, go right.
What did it say?
Right?
Yep.
That makes sense to me.
If val equals
Current value.
Okay, that makes more sense.
sweet. But it's not if it's not if it's equal.
Hmm.
Is it?
Let me check.
This is again assignment 4, right?
Which function? Node remove.
Yeah.
We don't even have a function called node remove.
Really?
Side node contains
We have remove node.
remove leftmost.
No,
Remove
it's right below
remove
that.
node. Okay, I see. So first we compare if it's equal. If equal, and then yeah,
Yeah.
it is equal.
It is equal. Okay, sweet.
I guess.
Yes. I was just about to do that.
Left justifying.
That's right.
Somebody's got to do it.
All right. Moving on.
AVL practice.
Let's do this.
I can't do this yet. I just watched the video, but I will do this sheet and have it ready to turn in. But this is there's a little video that explains it. It's a way of balancing an unbalanced BST.
Wait, which one are you on a different sheet now?
Yeah, the first one. What
called-
does what does AVL stand for?
It's the people that made the tree. Their names are Aldelson, Velsky, and Landis.
That's a
Rush.
horrible name for a tree.
Oh, it's actually just two guys.
Okay. So what's the difference between this and the binary?
If you pull up worksheet 31, you can see.
Okay.
Oh, good.
So when we have a completely unbalanced binary tree, it's 1, 2, 3, 4, 5, right?
Yeah.
So in the instance 3, 4, 6, to balance it, you would need to make 3 the left child of 4, and then you're balanced again. So they call this the rotation, and in the case where it's 3, 6, and 4 is the left child here. No, I did something bad. Yeah, I guess that one. Then you have to do 2 rotations. Double. All right, so in order to take advantage of the AVL tree, you have to keep track of the node height.
Okay, and then just rotate.
Basically, whenever you add a new node, you go to the null spot, get the new node memory, assign the value, and then why don't we balance here? It's a good question. Else if
It's more of the LT.
I know. I can't do like a small.
I use spaces.
Okay. Else if else. Mixing.
This actually looks pretty complicated.
So here's a question for you. Is this supposed to be underscore here? And this is recursive? And
I bet you're right. That's the same way the other ones would. It wouldn't change from how the other ones worked, really.
No, this function doesn't have an underscore. Does it? I don't know. Oh, it does. Never mind. Yeah. I think there should be.
okay. So we also don't set the height here. All right, armed with height information, AVL tree algorithms are easy to describe. Last step is to invoke the balance. Okay, so, and then we return to balance current node. So this is just like the binary BST.
What's the advantage?
We'll see in the balance code. All right, the function balance performs rotations necessary to restore balance in the tree.
Cool.
These should be called forest trees.
Why?
Forest tree.
Oh.
Okay, so
What's-
balance.
Yeah.
Int BF Okay, so this returns the balance factor. So if the balance factor is less than -1, go into this code. We need a double rotation.
Oh,
Otherwise, we just need.
I see.
Wait, they're doing these.
I get it. Yep. They subtract the heights of the two children, of the current right and current left, and that's how they come up with the balance factor. And that's what they use to determine, to test which solution they apply.
So H is
Sorry, it finally dawned on me what this is doing.
up here. So if the current. Okay, so H just gets the height.
Right.
So it gets the difference in height.
Where does it set the height?
Height is a function.
Yeah, but you have. There is a set height, but I don't see where it's called.
And it's not.
It's called way up in struct AVL node.
So that's passed in when they create the node.
Yeah, but here's where we create the node and add AVL node add, but there is no height.
Go higher.
Here's a set height, but we don't call that.
It's not called.
So I guess we have to call it somewhere, but I guess maybe it's not in.
Wait, why is Rennie in our?
Yeah,
Do you see it?
I saw her in there,
What? Why?
but she's not on the call.
And she's like,
Lord. Why is she looking at our worksheet?
Help her team out.
She's stealing our stuff?
I mean, she's in multiple groups.
yeah, she's like a bird.
Or a traitor?
Ouch.
You know this will be posted publicly.
Oh, right. I forgot. Just joking.
It's okay. She's definitely not gonna watch it. So
Yeah.
Yeah, who's going to watch this?
I bet Samina looks at it for like 10 seconds and is like, okay, full credit, I'm done.
You can pretty much say whatever you want. Okay. So,
Okay, so if we need a double rotation, that means that we're going to rotate left. Right? And these are also, but we have to.
That height is called in rotate left.
Okay, so
Rotate right as well.
right, so we're going to rotate left and then rotate right. And if it's greater than 1, we're just going to rotate right and then rotate left. Oh, man.
this is really confusing.
Yeah, I think we're going to have to write code to understand what is going on. And then we set the height at the end. There we go.
At the end.
And then we return the node.
I understood the last part.
Okay.
We should revisit this after we write some code, because I don't really get this. I understand in loose terms what it's doing, but but certainly
Yeah.
not enough to use it. So, you
Right.
know, I need to finish studying it. I haven't really studied it yet. So,
I'm
I
just
had,
not clear on the rotating. Like,
Well, luckily they don't provide any of that code for us, but we're so smart. We'll figure it out.
okay, so rotating only rotates 3 nodes.
Uh,
I'm not picturing when rotate right and when rotate left is used.
yeah.
I'm trying to picture rotate, so it switches the nodes, like the nodes' positions in the tree.
Yes.
But how many nodes are they rotating? Is it 3 nodes or the whole thing or what?
I think it's just going to be, so it's linked list, right? So you can just shift
2.
2 and then you rebalance everything below that. Maybe?
Like it says rotate right current. Current is rotated to where?
So if you're looking at 3, 4, 6, and you're going to rotate right, yeah. I think we should reconvene after we figure
Yeah.
this out.
I would get a lot more out of it if you let me study it, and then we'll come back and you guys can explain it.
Yeah.
I need to study it a little bit. I'm sure there's a YouTube video that does a great job of
Yes.
stepping through this. You know.
Yep. Guaranteed.
Let's
Yeah.
table it for the night for that one anyway.
Sounds good.
Is that all right?
Yep.
When are we going to meet up again?
Zach likes it. I don't know.
Sometime
Tomorrow?
soon.
Next week?
Next week. You don't really want to this week, do you, Ryan? I mean, you're slammed with stuff to do.
Yeah, but I got to finish this too, so. Tomorrow at 4?
No,
6,
we don't
8?
have to finish this. I mean, we had to finish the worksheet, but there's no homework on this.
Oh, there's no homework?
This is worksheet for next week.
We have homework due Sunday though, right? Assignment 4.
Yeah, that's right. The worksheets are due Saturday, like always, and the assignment 4 is due Sunday.
Yeah, I got to do assignment 4 too.
You have a lot to do.
All right, guys. Let's talk tomorrow.
Sounds
Okay.
good.
Okay.
Energy drink time. I'll see you guys later.
All right, talk to you later.
Later.